See students, in this class we are going to discuss coordination compounds. So D and F block elements coordination compounds is combinedly we have to discuss in this chapter. So D and F block elements is over. Then we are going to discuss coordination compounds or complex compounds. Coordination compounds. Coordination or complex compounds. Already I give an explanation about already I told in the previous class and I give an explanation about complex compounds. They are nothing but which having a central metal atom, cations or anions and ligands. Ligands means some other neutral molecules. So coordination compounds which contains a central metal atom, and second one cations or anions, okay. Third one ligands means some other molecules. Some other molecules are called ligands. For example, if you take CO, Cl3, 6NH3, here CO central atom, Cl is anion, NH3 is a ligand. NH3 is a ligand, which is the combination of a complex compound. So, for briefly discussing about coordination compounds, we have to know Werner's theory of complex compounds, because Alfred Werner is the man given brief explanation about coordination compounds. Alfred Werner is the man given a brief explanation about coordination compounds. What is the shape of the coordination compounds? What is the coordination number? What is the primary valency? What is the secondary valency? Like that all we are going to discuss. So here you have to know Werner's theory. It is a very important theory. Werner's theory. See here, according to Werner, transition metal act as a central atom. Okay. So central metal atom having two types of valencies, primary valency and secondary valency. Okay. See here, postulates we are going to discuss. Transition metal act as a central atom. Okay. So metal atom having two types of valencies. So metal atom having two types of valencies. Okay. So first one is primary valency. First one is primary valency and second one is secondary valency. Second one is secondary valency. So what is primary valency and secondary valency? We are going to discuss. So primary valency means which is equal to oxidation state of central metal atom. It is equal to oxidation state. OS means oxidation state of central metal atom. Central metal atom. Okay, it is equal to oxidation state or oxidation number. Oxidation number of a central metal atom. Okay, here it is equal to secondary valency is equal to coordination number of central metal atom. It is equal to coordination number. Coordination number of central metal atom. Coordination, it is equal to coordination number of central metal atom. What is coordination number? We are going to discuss. See next here, it is denoted by dotted lines, and dotted means like this. It is denoted by dotted lines. It is denoted by thick lines. It is denoted by thick lines. Okay, like this. It is denoted by thick lines and it is denoted by dotted lines. So when we are going to draw structures, you may know all this. Okay, then it is ionizable. It is ionizable. It is not ionizable. It is not ionizable. When it is dissolved in water, so primary valency can be dissociated into its ions, but secondary valency does not dissociates. That is nothing but ionizable. So it is ionizable. It can't predict geometry. It can't predict geometry. It can't predict geometry. It can predict geometry. Okay, it cannot predict geometry. It can predict geometry. So this is primary valency and it is a secondary valency. It is equal to oxidation number of central metal atom. It is equal to coordination number of central metal atom. Coordination number means number of ligands present in the central metal atom. We are going to discuss. So it is denoted by dotted lines. It is denoted by thick lines. It is ionizable. It is not ionizable. It cannot predict geometry. It can predict geometry. Geometry means shape of the molecule. So it is primary valency and it is a secondary valency. Now I am going to explain with the help of an example. I am going to explain with help of an example. Now you may know. So it is coordination complex compounds. So which having central metal atom and cations or anions, ligands, and ligands means how many ligands are present here? 6 NH3 means 6 ligands. So CO is the central atom and Cl3 is the anion. Now Werner's theory, we have to discuss about Werner's theory. The man Alfred Werner can be treated as a father of coordination chemistry. Why? Because he given encounter explanation about the coordination compounds, how coordination compounds formed, how the shape of the molecules, and what is the terms present in that. So briefly explained. So the need is arised to discuss about Werner's theory of complex compounds. So here transition metal act as a central atom. So here central metal atom having two types of valencies, primary valency and secondary valency. So primary valency having properties like this and secondary valency having properties like this. Now we are going to discuss examples. Example. See here. Example, CO Cl3 6 NH3. So this is the molecule I am going to explain. Here I have to draw its structure. Coordination number is 6. So here primary valency equal to +3, that is equal to oxidation number equal to +3, oxidation number equal to +3. Next secondary valency equal to 6. How many coordination number? This is equal to coordination number equal to 6. Okay, CO means coordination number. Already I told you, see coordination number is nothing but a CO. So here central atom is CO, anion is Cl, ligands is ammonia. So here I am going to draw its structure. CO +3, which can be act as a central atom. So it having 6 ligands means which having octahedron shape, NH3, okay, here it is NH3. So it is coordination number. Coordination number decides the predict the geometry. It is a octahedron. Next, how many chlorines? 3 chlorines. So 3 chlorines are denoted by dotted lines. So Cl minus and Cl minus and Cl minus. So it is a primary valency. It is a primary valency. It is a primary valency. Here this is a secondary valency. So it is a secondary valency, secondary valency. Understand? So this is example. So this is nothing but 1, 2, 3. Primary valency is denoted by thick lines which forms coordinate covalent bond with central metal atom is called ligand. We are going to discuss. Then secondary valency is denoted by dotted lines. So which is ionizable. So how many chlorines? 3. So oxidation state is plus 3. How many ammonias? 1, 2, 3, 4, 5, 6. So coordination number is 6, which decides the shape of the molecule. Understand? So here primary valency plus 3, oxidation state, secondary valency 6, coordination number. See, one more example we are going to discuss. So that is COCl3 for 5NH3. COCl3 5NH3. So then one more example. COCl3 5NH3. So here only 5 ammonias, 1 chlorine satisfies primary valency and secondary valency. So here primary valency is equal to 3. It is oxidation number equal to plus 3, and secondary valency equal to 6. It is a coordination number that equal to 6. Okay. So coordination number 6 means shape of the molecule is here, shape is octahedron. Shape of the molecule is octahedron. Here coordination number. So it is the central metal atom CO plus 3. So which having so here NH3, here Cl minus, okay, here NH3, here NH3, 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 okay. So here it is a Cl minus. So it is Cl minus, Cl minus. So total 3 chlorines, 1 chlorine satisfies primary valency and secondary valency, and 2 chlorine satisfies only primary valency. It is primary valency, it is a primary valency, it is primary valency and secondary valency. So remaining all are secondary valency. So like this, it is a secondary valency. So here what I mean to say, central atom CO plus 3, ligands are 5 ligands are ammonia and 1 ligand is a anion. So it can be act as a, it can satisfy primary valency, it satisfies primary valency and secondary valency, then remaining only satisfies secondary valency. So remaining these two satisfies primary valency, remaining 5 satisfies secondary valency. So coordination number no change. Why? Because in the place of 1 ammonia, so chlorine is joined. So coordination number no change, that is a 6. So shape of the molecule also no change, that is a octahedron. Shape also no change, that is octahedron. It is the shape of the molecules. Okay. So here it is a example, second example. So one more example we may draw. So like this, that is nothing but a example Cl3 4 NH3 Cl3 4 NH3. Okay, so here primary valency is primary valency equal to 3. It is oxidation number equal to plus 3. Oxidation number equal to plus 3. So secondary valency equal to 6. It is a coordination number. It is equal to 6. Okay. See here, central metal atom is a cobalt. So CO plus 3 can be act as central metal atom. No change in its shape. Why? Because coordination number is 6 only. So here how many ammonias? 4 ammonias. So here NH3 and NH3 and NH3. Okay, here 5 ammonias, here 4 ammonias, means 1 chlorine satisfies only Cl minus, only primary valency, and 2 chlorine satisfies primary valency and secondary valency. Cl minus, so Cl minus, it satisfies both primary valency and secondary valency, primary valency and secondary valency. Here also primary valency and secondary valency. It is only secondary valency. It is a 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 primary valency. Then it is primary valency and secondary valency. So this is shape of the molecule is octahedron. Octahedron. In this one, 2 chlorine satisfies primary valency and secondary valency. That's why we are indicating dotted lines and thick lines. Dotted lines is secondary valency. Dotted lines is primary valency, thick lines is secondary valency. So this chlorine satisfies both valencies. That's why we are indicating like this. Okay. So it is example 1, 6NH3, 3 chlorines. This is example 2, 5NH3, 3 chlorines. It is 4NH3 and 4 NH3 and 2 chlorine satisfies both primary valency and secondary valency. This is Werner's theory of complex compounds. In next class we will discuss ligand and types of ligand, coordination number like this. Okay.